Okay, let's jump in. I think we have a quorum, and I'm sure more people will be joining on. Hello, everybody. My name is Anton Brevde. I'm a partner at Prime Movers Lab. I want to give a big welcome to people I see here on the attendee list, some of our LPs, founders, people from the extended Prime Movers Lab family. Special welcome to the new Fund 2 LPs that have just joined us. We're excited to be in partnership with you. For those of you where this is the first time that you're meeting Prime Movers Lab, we're an early stage deep tech fund. We invest in breakthrough scientific inventions that have the ability to impact billions of lives across sectors like energy, infrastructure, manufacturing, transportation, human augmentation, and the future of computing. And today we'll be discussing large scale energy storage, which is one of the subsectors that we're quite excited about. And we're really lucky to be joined by some amazing panelists today. This is the last of our inaugural 8-part tech webinar series that we've done, and hopefully some of you have joined for some of the other episodes we've done on longevity, space, batteries, lots of interesting different topics. The idea behind the webinar and the inspiration behind the webinar is one of the really amazing aspects of being an investor. One of the favorite parts for me is the caliber of experts that we get to interact with, both internally with people like Dan, founders like Rob, and experts like Ramez and Prime Minister Harper, who we're extremely lucky to have as an advisor to the fund. We get to sit with some really amazing minds around the table to help us do our job of diligencing these companies and supporting them. And it's an important part of what we do, but it's also important for us to share some of that knowledge. And so the white papers and the blog posts and these webinars are an opportunity to do that and give back to the greater ecosystem. So we hope that this will be of value to the audience. Yeah, keep an eye out. We've had some good feedback on these webinars, and we'll continue to do them in the future. And some quick housekeeping. We'll keep it to an hour long, so we'll end at the end of the hour. We would love for people to submit questions. You can do that via the chat or the Q&A. Feel free to do it whenever you'd like. We'll start getting to them probably at the 45-minute mark. Yeah, let's kick it over to my colleague Dan for a quick intro before we get started.
Friends, I'm one of several partners here at Prime Movers Lab with a physics background, and I've spent most of my career in hardware R&D and applied science. The topic today is large-scale energy storage, which I think is an overlooked topic that we might, often feel happens over there, but that really affects us all. This is sometimes called grid-scale storage or stationary storage. What we really mean by these terms is that these technologies are capable of storing energy in the range of tens or hundreds of megawatt hours. Grid-scale storage doesn't necessarily mean it will be tied to the grid, just that it is capable of storing enough power to meaningfully power, a city or big industry. And being so large, it probably isn't going to be portable, so hence the stationary part. So the reason this is important is because this will really enable the continued rollout of renewables in the future. Renewables have intermittency challenges in that they don't always generate the electricity in a smooth manner or when we need it. And the truth is there's energy all around us. Electricity is only one form of energy, though it's the one we're most familiar with and probably our most versatile type. But there's many ways to store energy, and rarely is it stored directly as electricity. Supercapacitors and superconductors come to mind as some of the only ways that we have to store electricity directly. So you can store energy by lifting heavy things uphill and letting them fall or roll back down when you want the power back. Believe it or not, over 90% of all the energy stored on Earth today is done with what's called pumped hydro, where you pump water uphill into a reservoir when power is cheap and you let it flow back down to turn a turbine when energy is expensive. That's a form of gravitational energy storage, and as Rob will share with us today, there are other ways we can harness gravity for this purpose. We can also store energy as heat, such as in molten salt reactors, or as kinetic motion using flywheels. And I'm really excited to talk with with our panelists today on how these technologies will really be shaping our future.
Awesome, thanks, Dan. So let me kick it over now to the panelists, which is why we all tuned in to watch this webinar. Maybe we could go with Ramez, Rob, and then end with Prime Minister Harper. And then I think it'd be great, Prime Minister Harper, if you could maybe kick us off and explain kind of why this matters in the greater energy landscape and how it fits in. And in addition, when you guys do your intros, maybe also kind of explain what your relation is to large scale energy storage. Ramez, kick us off.
Hi there. Thanks so much for having me here. My name is Ramez Naam. I'm the co-chair for Energy and Environment at Singularity University. So I'm actually a lapsed computer scientist. I spent most of my professional career in tech at Microsoft, and I watched the price of computing fall like this. And then about more than a decade ago, I got really interested in climate change and started to look at climate solutions and found this incredible trend in the plunging cost of solar and plunging cost of batteries as well. So now I'm an investor in clean tech companies myself. I put together SPVs for that and so on. And to me, the reason that storage matters is that we're in the process of totally inverting everything we think about the grid. We normally think about base load power, things that are steady producers, and that's something like a coal power plant perhaps is a cheap, steady producer of electricity. But now what we're finding is that we have a new concept of base price, which is that the cost of renewables has plunged so fast. The cost of solar panels per watt has dropped by a factor of 350 over the last 40 years. And just the last 10 years, the price of solar electricity has dropped by a factor of 10. Price of wind electricity has dropped by a factor of 5. So now it's irresistible to use these clean electricity sources, but you have to deal with the intermittency. And there's many ways to do that. You can pair them together. Wind and solar are complementary. You can do smart demand. You can program, use a digital technology to control when demand is sucked down. But storage ultimately has to play a role. And there's a lot more that we have to do beyond just batteries as we know them today. So I'll stop at that point and let others introduce themselves.
Rob, how about
You want to hop in?
Yeah, sure. Nice to meet everybody here. Rob Piconi, I'm co-founder and CEO of Energy Vault, which is topical for this conversation because we're focused on utility scale and longer duration energy storage. I began my career in diversified energy for a company. Some of you, I'm sure, remember Amoco, US-based large integrated oil company that merged with British Petroleum. So I started there. In the later 90s, as the internet started to take off, I found myself spending all my time on computers and looking at technology and how the internet was changing, fundamentally changing how we interact and do business. And so I shifted to Bell Labs and spent some time in networking and for the next phase of my career. And just interestingly, toward the end of that, met Bill Gross from Idea Lab, who I know, I think most of you know, and really caught on to his passion around renewables and developed a relationship starting 12, 13 years ago with him, focused on interactions, looking at working together in renewables and then in energy storage, which is what we chose to do toward the end of 2017, which for me has been very fulfilling because it sort of brought together where I started in diversified energy and then looking at networking and data and software, and now coming together. If you look at what we're doing and with Energy Vault, is we're combining sort of conventional physics with computerized control and machine vision software to create a very innovative and low cost way to store energy, which, in addition to the fact that Dan shared about pumped hydro being the primary basis for how we store today, which really was the inspiration around our company, which I'll talk about later. The other fact that's interesting is electrons and electricity uniquely is one of the few things that costs a multiple to store it than it does to create it. And as Ramez just talked about, how generation now from solar is so cheap. The issue is in fact storage and storing economically, so we can actually have renewables replace fossil fuel for dispatchable power. So anyway, it's a pleasure to be here and look forward to contributing to the panel today.
Yeah, I'll jump in. Well, first of all, thanks Anton and Dan and everyone at Prime Movers Lab for having me. I think most of you know my background. I was Prime Minister of Canada for a decade. I'm now run a consulting business globally. We are investors and businessmen. And we look to do a lot of, we really look now to be involved in things that we were involved in. I have a team from government that take the team from government that was involved in public policy and look at how we can pursue some of those public policy objectives now through private business. And look, just first right off the top, delighted to be associated with Prime Movers Lab. I think it's fantastic what you do, taking a combination of high tech and science and figuring out how you can commercialize this and not only make a lot of money, but make a big difference in the economy and society going forward. So look, I will begin, Anton, if you don't mind, by disavowing any degree of expertise. I tell people I'm an economist by training. I was a computer programmer a long time ago. I worked in the oil and gas industry, but I would not claim to be an expert in long-term grid storage. When we were in government, obviously we were looking at the whole area of environment and climate change that is such an important driver of investments like this, and for reasons that we all understand. But I can tell you, ironically, that this was not an area in terms of all of our environment and climate change investments. This was not an area that we were focused on. Now you'd say, why not? Actually, there's a pretty simple reason. In Canada, the electrical system, the electricity provision and the power grid are run by the provinces exclusively and not by the federal government. So, any of our investments in this area tended to be in other parts of the space. However, I am an equity partner in an energy tech transition fund out of Calgary. Actually, we're headquartered both in Calgary and the Bay Area, called Azimuth Capital. And so through that, I do have some exposure to decisions being taken in these areas. So why is it important? Obviously, climate change I mentioned, and I'll repeat what some of the others have said. Well, prices of renewable energy production have fallen dramatically. They really have. The problem of intermittency is still enormous. And the intermittent nature of renewables means that really to effectively use their potential over time, we have to have better ways, more economical ways, and larger scale ways of creating storage. We have existing battery technology. Existing battery technology simply doesn't fully address these issues, and I think a lot of us who have looked at this think it's unlikely to fully address these issues going forward. I would also add that there's one other set of issues that it's kind of a sidelight here, and that is the security issues. Look, I won't get into this, but I had a number of scary briefings when I was in government from our security experts on the vulnerability of the power grid and the electricity system. It's a big reality in modern societies, and obviously having long-term storage, better long-term storage capacities could also address that issue. As I say, the other panelists will be much more knowledgeable about the specifics of this than I will. Let me just say this, because I think it'll be an interesting dialogue. At Azimuth, this is not our focus. When we're looking at the various investments we've made, we've not invested in this area. And, I'll obviously have some reasons to share for that later, and be interested to hear why our panelists are invested in the area.
Cool. So, maybe it makes sense to explain the difference between long duration and short duration energy storage, and kind of how the economics change between the two. I think that'll frame a lot of the rest of the discussion. Ramez, do you want to kick us off there?
Sure thing. So people think a lot about energy storage, and when we think about energy storage for solar or wind, a lot of what comes to mind is, hey, if I've got solar, if I could just have enough energy storage to store it overnight, that would solve my intermittency problems, right? That's a simple way to think about it. But it turns out it's not that simple. There is the highest economic value is in relatively short duration storage. Electricity demand peaks for a few hours, usually in the late afternoon or evening, especially in sunny places in summer. Appliances are on, people are at home. If you're in a sunny location, air conditioners are running. So those, 4-hour storage gets you a lot of economic value. But the problem is that you don't have just the day-night cycle, you have weather and seasonality. And so between winter and summer, if you're in a northern latitude, as Canada is, or if you're in, say, Germany, the solar output in June or July is 5 times what the solar output is in December or January. So you have this massive shift. So are you going to overbuild your solar by a factor of 5? Well, you can build wind. Wind is complementary to solar. Solar is only daytime. Wind statistically peaks at night, but it can blow anytime. Wind is a spring and winter peaking resource, when solar is a summer peaking resource. That's convenient, but still you have situations like in Europe last winter, when there's no sun in Northern Europe. In the UK, we had a 10-day wind drought in the UK, where the wind just basically wasn't blowing. So it turns out that if you want to decarbonize the grid, it gets sort of asymptotically harder as you approach 100% decarbonization. Getting solar and wind to 20%, 30%, 40, 50%, even maybe is great. If you build some large-scale grids, some smart software controls, a few hours of batteries, 70%, 80% might be viable. Depends on your geography. Easier some places than others. But squeezing out that last 5, 10, 20, 30%, depending on where you are, gets harder and harder. And so you have to start going from batteries that last for just a few hours, but that have the advantage from a price standpoint of discharging every day, and thus getting to get their value, 365 times a year, to batteries that might be able to store a week of power, but that might only discharge twice a year. And because they only discharge so infrequently, because they have far fewer times that they sell their power into the grid. Think of a battery discharging is like a generation resource. When a battery puts energy onto the grid, it's like a power plant putting energy onto the grid. It's a generation resource that you can capture value from. But if you only do it twice a year, you have to get that cost underlying it really, really cheap to make those economics work out. And that's where innovative ideas like what Rob's working on at Energy Vault and a host of other things, I'm an investor in some other areas like flow batteries and so on, become an alternative to batteries as we know them today to try to solve those storage problems that go beyond hours and into days and maybe more than a week.
Ramez, that was super helpful. And one of the questions that I imagine people have listening is, you mentioned that it's that last marginal amount that becomes much more difficult to do. What is the importance of getting that last 30%? Why not just start with the first 70 and call that a win?
Well, I think that's one of the challenges, because in fact, that's what the power grid is doing. What's happening is, if you go back in time 5 years, the storage projects that were being built out had half an hour or an hour of storage, and they were tiny. Now, the average storage project being built out has probably about a 4-hour duration. And you see in the US, at least where I am, an awful lot, a large fraction of the solar projects being built now are coming with 2, 3, 4 hours of storage, because that's what's economically advantageous, because it's very predictable that at night, if you're in Texas or Florida or California, on those summer nights, the sun starts to go down, 6, 7 p.m., whatever time it is, but the AC is still running and the appliances are still going until the TV is still on till 10 p.m., let's say. That's an expensive hour. That's very valuable. The grid is not yet really economically seeking that multi-day storage, but in some places, governments are looking ahead and saying, if we want to do deep decarbonization, if we want to actually get to zero emissions and not just to reducing electricity emissions by 70%, then we have to solve this problem. So really, you'd have to look to Europe as the place that is the most progressive in terms of thinking ahead, in terms of how do we solve this long duration storage problem. And probably most Europeans that actually think about this would tell you that hydrogen is the most obvious answer. It's the one they know. Take excess power when you don't need it, use it to electrolyze water, split it into hydrogen and oxygen, store the hydrogen, and you can then hang on to that for days, weeks, months, a year, and then burn it in a combined cycle fuel plant when you need it on some winter day when the wind isn't blowing at all. While that's the way Europe's going, there are dozens of other technologies like Rob's that I think are contenders that might be more compelling than hydrogen.
And we'll get a good chance to talk about a couple of those. One thing I just wanted to highlight there is, because it's kind of non-intuitive, that the duration of the storage kind of affects the cost of what you're willing to pay for it. If I heard that right, the longer you intend to store the power, the cheaper it needs to be. And so we can't just look at dollars per kilowatt hour or something like that, unified across all different storage media, that if it's long duration that it's targeting, it really needs to be a cheaper dollars per kilowatt hour than, say something that's fast discharge like chemical batteries, lithium ion batteries.
That's right. And I think of it, you can think of it a slightly different way. How many times does it have opportunity to sell its power? Really? A lithium ion battery that's got a 4-hour duration has an opportunity to sell power every day for 4 hours. So it can sell, 4 hours times 365, 1,200 hours, 1,600 hours of power per year. So its capital cost is amortized over all those units. But if you've got a battery that's supposed to last for 10 days, 240 hours, but only discharges once, then you have to bring the price down by a factor of 4 or 5 or 6 to make that worthwhile. Or the grid is going to have to compensate, going to have to create incentives to have that sort of firm, seasonal, long duration storage resource available.
Yeah, so I'd love to hear from Rob on this, because Energy Vault's working on a very unique solution for this long duration storage.
By the way, I think it's a great segue. And as we think about why shorter duration, and Ramez, you mentioned that speak short durations there because it's actually economical and batteries selling into this peaking. There's the equation we're solving for, and I think Prime Minister Harper, I'm sure, in looking at from a large country level and looking at policy, if you look at what's happening in many parts of the world, you've got energy demand that's actually growing in a lot of large developing countries. So you've got an equation where we have fossil fuels that are still being built out. Coal plants, believe it or not, are still being built out in many parts of the world. And why? Because we can't get storage solved to make renewables, despite them being so cheap as base load. You've got energy growth or demand growing, and so you're in this race to keep up. And at the end of the day, we've got carbon that's emitting and growing our temperature on the planet. So it's a complex equation. And so as we looked at solving this, and shorter duration, I agree 100% with Ramez that it's the core market today, because utilities are looking at shifting in the evening and then in the early morning. I'm in California, for example, where we're still having rolling blackouts, and actually they call them greenouts because we produce way too much during the day, for example, in solar, but then have other issues. We have fire issues, so they have to shut down parts of the grid because of the danger. So we have a lot of issues that we're solving for. We focused on longer duration to start in coming to market because, in addition to the public utility and residential demand, you've got industries that are consuming tremendous amount of power, tremendous amounts, 24 hours a day, that also has to be served. So, for example, desalination plants that run 24/7 and require, essentially between 4 to 6 megawatt baseload power, all the time, they need to run at night. They're typically in places where you've got plenty of sun, but then the issue of longer duration storage. And unless you're built next to a pumped hydro facility, there's just not a lot of solutions for that longer duration. And you can go up the stack in terms of looking at liquid metal plants or even cement plants or concrete manufacturing, which sucks over 40 megawatt base load essentially to run. So longer duration was important as we looked at the market and what was going to be happening. So in terms of it, and I think we started 2 hour, now 4 hours, as Ramez said. And I think we're getting into situations given energy demand growth and the need to service the industrial segment that longer duration it is going to become more and more important. And I think we probably would universally agree with that. The issue are the economics, as has been discussed. And with more conventional or lithium ion batteries, you get degradation. So it's very difficult and becomes very expensive to actually store the energy. And energy gets measured, and the cost of storage is much, much more expensive, for example, than the cost to generate renewables. Renewables are a few cents a kilowatt hour. I was on the phone this morning with the largest oil company in the world, and their wind, because of where they are, is actually less than a penny a kilowatt hour there. They get 12 meters a second, and they are looking at making this change and investing heavily in storage. So the issue is storing and storing economically, and that's where for the longer duration becomes very, very difficult. You can't go build pumped hydro facilities. They can't build them everywhere, and plus they're billions of dollars and they hurt the environment, which is another issue with chemical batteries. You've got a lot of environmental issues in solving that. But it really, in the end, it comes down to solving for that economic equation and doing that in an environmentally friendly way and in a scalable way. And that's where, for us, it took a lot of innovation to look at a way to sort of mirror the benefits of pumped hydro, which is ultimate duration, but has a lot of issues, other issues that you want to solve for to get something scalable and environmentally friendly. And at the end of the day, to solve that cost equation, which at the highest level, what we wanted to achieve was looking at something where you combine wind and solar as generation at a few cents a kilowatt hour with storage at a few cents a kilowatt hour. And you could have something that is, for the first time, competitive with the cheapest type of fossil fuel generation, which is arguably combined cycle natural gas between 5 and 6 cents. And that's, while there's government incentives and things that the governments do to help incent renewable investment in generation, at the end of the day, if you can innovate enough to get the economics and something that ideally doesn't degrade over time, then you can get into economical, not only economical shorter duration, but economical longer duration storage. And that's where we focus.
Thanks, Rob. But maybe we can use that to hear a little bit from Prime Minister Harper on the role of regulation and governments in kind of progressing this technology forward and getting it scaled up, and maybe also sharing a little bit of insight on, how do governments weigh the different trade-offs here, right? Because these decisions have positive and negative externalities. So if you were back at the helm and at running a national energy policy, how would you think about this?
Yeah, well, first of all, just comment on the government space here. I think what Ramez said is accurate. I would say Europe is leading on this, at least on the kind of the regulatory and public policy front. But actually, the United States is still where there are the leading investments. And they could use a more favorable regime. In most places, to my knowledge, there's no favorable tax treatment or investment tax credit around this space as there is for, say, solar or wind. So I think that a case could be made to put this on a more equitable footing from a tax standpoint. Also, in terms of long duration energy storage, there really is no kind of comprehensive market system built around it. So governments could have a role, as I think Robert suggested, in creating some incentives to provide for better long duration energy storage in the absence of that. Look, I would just say this. All governments think about this in different ways. Here is how I would think about it in government. First of all, you want to create a kind of a level playing field. And you want to create incentives, but you ultimately want to drive these things towards good long-term economics, because that's the only thing that really works. And if I can maybe just elaborate on it, because I think there's been a good explanation of the economics. But when we're talking about this area of climate change, we really have to keep a global focus. And it's great to say that these advances are being made in a place like California. But the reality is the growth of global emissions around the world is going to occur and is occurring in emerging economies. And regardless of the economics today of renewables, they have no use or limited use for intermittent power sources. I mean, all of their needs are to develop base power capacity. And to say that, you know, it's really cheap when it's working is kind of a pretty big when. So this is why, as I say, this is so important to get these storage capacities, get them working around the world. And as I say, I think the role of government is to create some incentives and to try and beyond regulation, what I have advocated to governments in the last few years is that I think government should become a co-investor in a lot of these things. You know, right now governments go out and my government was the same. They pour trillions of dollars in subsidization, in grants, et cetera, these various projects. And that may be great to the people who are operating them. But in the end, you know, what actually justifies an investment is that you make money off of it. And my view is if the government's going to put billions of dollars in and really drive good outcomes, it should be putting billions of dollars in with the expectation of return. And so, look, that's, I think, something that's been undervalued by governments. But I think the other thing that governments have to take account of, and I think, you know, the investment community also, we can't be focused solely on greenhouse gases as the only environmental challenge. I mean, right now, as has been mentioned, pump hydro is 95% of all long-term storage projects are pump hydro. They have enormous environmental challenges of their own. Batteries have enormous environmental challenges. So I think governments and others could be using a little bit more judgment in balancing some of the environmental risks, because there's almost none of these options come with zero environmental impacts.
Either of you guys have more thoughts on how government could play a role here?
I would just offer that, you know, a lot of the innovation to address these issues obviously comes from the private sector. And I agree with the Prime Minister that at the end of the day, pure economics should drive. And I think there are areas around policy, and whether it's tax incentives or carbon pricing policies, et cetera, at the end of the day, I think private enterprises are going to make decisions, both obviously for profit optimization and to drive their businesses, but also, especially with what we've seen the last, I'd say in particular, the last 12 to 24 months is in this umbrella of social responsibility. What I'm seeing in just this last year is companies and private enterprises acting to drive change. And you see some of the largest companies in the world that are dictating to their power companies that unless you're providing me green energy, I'm not going to buy your power, and I'm going to build out my own power, for example, and I'm going to build it out renewably. And so I think there's a role that absolutely I think the government's playing in ensuring that incentive structure is in place. But at the end of the day, it does have to come down to core economics. And to the points the Prime Minister just made, the environmental ones, fundamental, as just to share what we looked at, as we looked at looking at a solution to solve this problem. And there's, you know, we need everything we can get. So we took a certain approach, but one of the fundamentals was the environmental side. As we looked at solving this problem, we did not want to do anything that was going to hurt the environment. As an example, that was a premise. We wanted to solve this based on pure economics without incentives. That was a premise for us. So I think that is absolutely fundamental. And that's why when you look at technology, I think as investors, it's fundamental and I think important to look at, you know, technologies that don't have some, you know, hidden liability at the end of the road. Or, you know, for example, people look at what we're doing with Energy Vault, where we're using gravity and we're using these composite bricks, for example, and it's all orchestrated by software, where we essentially take excess wind and solar or any power source, and we use potential energy. We stack them in a predefined way, and then discharge the electricity when the grid or the customer needs it. You know, people look at that solution and they see concrete. It's not concrete. We eliminated concrete from our equation because it produces 7% of the greenhouse gases, as an example. So I think I would like to see, and I think the governmental policy address not only for storage, as the Prime Minister outlined, something akin to what's been done on the generation side of renewables, but as well as looking at carbon pricing and CO2 emissions, and thinking about how that type of environment will influence corporate or private enterprise decisions. Absolutely. And then really let innovation drive, and that's that's how, it wasn't an easy equation to solve for, as we look to innovate and solve for some of the things to get to a very low levelized cost of storage that was environmentally friendly and could scale. That is a challenge, I think, with storage, and just need more, I think, innovation to address that challenge.
Yeah, super interesting. I'd love to jump in here if I could. So a lot of great things that Rob said, and I agree with a lot of what Prime Minister Harper said. So a couple of things. Yes, it is true that there's some companies that are really leading the charge. Consumer brands want to be perceived as clean, so they are doing massive clean energy buys. And so far, they've been doing them in such a way that they don't actually have to account for what time the energy is produced. So in the US, for instance, you can buy a virtual PPA from a solar or wind farm. And as long as the output of that solar wind farm over the year matches how much your facility uses, you can say, my energy is clean. But now we see some companies leading the charge to say, well, that's actually kind of BS. We need to have actually what was a clean electron delivered to my facility at the time that I was using it. So Google has recently announced that its data centers will all run on round-the-clock, 24/7 physically delivered clean energy. And so now you have somebody out there. Google can do it because they're rich, their coffers are deep, because electricity is actually a relatively low fraction of their cost, because they're still sort of founder-led, even though their founders have officially left, and because their employees care deeply about the environment, and they're in a massive battle for talent. Tech companies, Google, Microsoft doing this, even Amazon, the laggard in the tech community, has done some stuff in this area now. So you see them leading, and that, I think, is a spur of innovation. But that only gets you so far. And that can only happen after some technologies are actually available for them to contract with. And so government has a massive role to play. I strongly agree with what Prime Minister Harper said about it's about economics. It's about what the rest of the world does. It's, only 15% of emissions right now are from the US. Globally, over a history of all the emissions to date, the US has a much, much larger share than that. But the reality is China, India, and so on, the best way that we have, or Canada has, or Europe has, to influence what happens in decarbonization in Canada, or in China, or India, or eventually in Africa, or Southeast Asia, is to make clean energy, including storage, so darn cheap that it just makes pure economic sense for them to adopt that. I wrote an article about this. If you go search online for how to decarbonize America and the world, it's a post I wrote on TechCrunch that talks about this dynamic. And the dynamic, though, does have some very favorable things, because government policies that first spur new clean technology breakthroughs in the lab with basic research and then scale them can help birth these things and help get them cheaper over time. So I'm an investor, me and my syndicate, we've invested in at least 5-6 different storage technologies out there, and half of them were recipients of ARPA-E grants from the US Department of Energy that helped them, to the tune of $1 million to a few $1 million, get the basic research done so that it was de-risked for me as an investor, at least partially. Without that, you'd have a lot fewer commercial investments in storage, with more we spend less in the US. Sorry, Prime Minister, I'm going to talk from a US basis here. In the US, our funding for clean energy R&D is less than the US annual spending on toothpaste. Right? So it's like it's not a meaningful amount. If we had more spending on R&D, that would matter a lot. But secondly, just scaling technologies makes them cheaper. So most technologies have what we talk about as a learning rate, or Wright's law, and computing talk about as Moore's law, which is as you scale the tech, every doubling of scale leads to some percent decline in cost. Now that slope is different for different technologies. Solar is extremely fast, 30%. Lithium-ion batteries, almost as fast, 25%, let's say. Wind, maybe 20%. Natural gas combined cycle turbine plants, maybe 3%. So you got to look at different technologies. But as an investor or a forecaster, what I look for is what technology will get cheapest the fastest as it scales, and then the power of government policy, whether it's things like tax credits, and Prime Minister Harper is right, we've got tax credits for solar and wind. We don't have a dedicated tax credit for a battery or long duration storage project. We probably should. But whether it's that sort of policy or policies like California and New York both have mandates to deploy certain amounts of storage by 2025, 2030, and so on, the biggest impact of those is not the amount of storage they deploy. It's that by deploying that amount, they drive those technologies down the cost curve. So that's the vital thing, is that scaling itself induces R&D. It induces private sector improvements to the efficiency of manufacturing, to the maturity of their technology, and so on, that makes the unsubsidized cost cheaper. And that's what then allows us to export it to the whole rest of the world and change them to the lever of economic self-interest.
Ramez, I really enjoy that. And I want to build on the point that you mentioned about the role of governments in funding that early research. We think a lot, our methodology puts a lot of focus on science risk versus engineering risk, and us as private risk capital, we don't think it's appropriate to invest into science risk. It's impossible to underwrite. It's a problem that's never been solved before. And so there needs to be someone funding science risk, and 100% with you that I mean, it's either going to be very wealthy, well-funded companies that have a mission focus, but a much more sustainable path is going to be governments that can fund that science risk, where private capital is not a good fit.
Yeah, and I mean, maybe to that point, we love seeing companies that have gotten grant money from ARPA-E, from some of the other organizations that do kind of take on that science risk. Some of our companies have received millions in grants to work on hard problems and to really de-risk them to the point where it now looks like, the science risk is retired, it's engineering risk. This is really where we'd like to come in and help you succeed, as an organization. So, we're really looking at that transition out of the lab, so to speak. It's time to commercialize. And there's a lot of different energy storage technologies being considered, and new inventions and breakthroughs making headlines every day, at least the headlines that I'm watching. So which ones look most promising to you? And are there any that you think are overhyped and might not make the best investment? Rob, this would be a good place for you to I'm excited to hear what you have to say here.
Well, look, we had, I think, some of the same considerations that you mentioned about government getting involved in funding science, et cetera. I say we being as Ideal Lab and working with Bill Gross, we looked at the gamut. So we had, exactly to your question, where should we go to seek to innovate, and how do we want to solve this, or have a solution to help get renewable energy storage deployed. There's a lot of things going on in battery chemistries. Some of this you can call science projects. Others, have been around for a while that are just now progressing. Even things over the last 10 years. There was a SPAC that went out in the market in lithium metal, QuantumScape, that has Volkswagen and other investors behind it. That's been 10, 12 years, which, I mean, the way I look at it is almost like a lifetime, because we started our company 3 years ago. The problem was now, temperatures rising in the world, and we're like, wow, we want to get something to market that was a requirement in a decent amount of time, that had some a good high probability of getting deployed quickly. hence how we solve the problem. So there's a chemical battery landscape that I think is absolutely worth the investment in science. That may surprise you to hear me say that, but it's because you can achieve some breakthroughs, and probably could be achieved with a chemistry potentially that doesn't degrade, for example, like lithium ion. That's one of the big problems. So you want to, and there's companies that are looking to do that, and using sulfur or sulfur oxide or other ways to solve that. So I think that investment, and especially given form factors, because we think about, we're thinking about sort of residential and time shifting. There's the commercial applications, there's form factor applications. So we're going to need a lot of different types of technologies. There's a whole nother area around sort of compressed and liquid air and more mechanical type of technologies. And those are, I think, those are more known, maybe a little more predictable in some sense. They have other issues, of course, of being, they're typically have to be fairly large in scale to get deployed economically, okay? And then you also have issues around the efficiency, or what's typically referred to as round trip efficiency, where it's essentially the net of, for every unit of energy you store, how much you actually put back out into the grid. And typically those solutions are anywhere from 55% to up to, on a good day, 70%. If I think pumped hydro can get to that. So I think I think where you have very large, massive needs, almost like pumped hydro, and you can justify that investment, I think there will be projects that make sense and are economical. Now, from an investor perspective, is that going to scale? Can you really scale that in volume? That's a question mark. We're in gravity storage, so let me just share. There's not another gravity storage company except ours that can really scale, because they have a dependency, whether it's they got to go deep below or they need mountains above to build a dam, like pumped hydro, for example. And the issue in that is getting really something that's investable and that really you can build without a dependency. So that was another, as you think about solving this, it's, you need to be able to have something that you really can scale, and not to build everywhere, because you can't meet every form factor. I mean, we have to build a building, for example, with our solution, we have to, we need gravity, so we have to build a structure. So not something we're going to go build in somebody's backyard or in the middle of a city. It's going to be built out where there's wind or solar, or where there's industrial plants. We have another product platform that is, doesn't have a rotating crane. It's actually just a vertical motion, and so that'll enable it to be built in other places. But I guess net, what I'd say from a technology perspective, I think what's important is, first of all, the premise, there's no silver bullet here, number one. Number two is we need the innovation and the investment, whether that's some through the government, I totally agree, and other people like Prime Movers Lab that are investing in technologies here, like they've done with Energy Vault. And then I do think it is fundamental to think about the premise of what you're investing in, okay? And I would be very careful to be investing in lithium ion. It's my opinion. Some people may disagree. There you have a lot of issues still that aren't solved. And even if pricing is going to go to what it's going to go to, despite you're going to need, HVAC and a lot of other infrastructure, and you're going to have this degradation, you have to think about disposal cost at the end. So there's a lot of things that still need to be worked out there. I'm not saying it's not solvable, but I do think people should think about, first and foremost, don't try to solve an environmental issue while creating one at the same time. So that should be fundamental. You need to think about, I think scalability is fundamental in this aspect of product market fit, and in the end of the day, economics. So at the end of the day, for us, that was actually the hardest thing to solve. We can use gravity and scale it. We can build cylinders, large concrete cylinders with water, and pump it. We had options to look at trays that are built almost like a parking structure, where you have trays of water that go from level to level. The issue in all of those and all the ideas, you could build them, but you couldn't do it economically. And what did that mean to us? That meant solving something where we could get below 5 cents a kilowatt hour. So when you combine it with 1 to 2 cent wind and solar, you could actually be competitive. So economically, people could invest in renewable without having the excuse, well, it's cheaper for me to build a coal plant or a combined cycle natural gas. So from my perspective, whether you're investing in the technology or or from a government perspective, you're looking at policy, I think there should be some very strict parameters on that. And I think, I'll finish with this. Elon Musk said it, I think yesterday. He's looking at and is innovating in looking at how, instead of lithium ion, using a different battery technology to solve this problem for utility scale. I think his quote was something along the lines of, we're restarting from scratch as we're looking at batteries, and that's the right thing to do. And I'll never count him out, of course, given his track record. So.
Awesome. Thank you, Rob. So let's try and sneak in some of these questions. We've got
maybe
quite
just
yeah, please.
Comment, in terms of options on hydrogen for a second.
Yeah.
Because that was raised, and it was mentioned that Europe seems to be betting on hydrogen. I just want to give a little bit of a different perspective. I mentioned in the green room that I'm involved in a company that has devised a way to produce carbon black from natural gas. Greatly reduce emissions, greatly reduce pollutants, et cetera. It's a great company. But one of the byproducts is that we now have a way of producing pure hydrogen. And there are, as Robert says, the technical arguments versus the feasible arguments. There are conceivable ways of using hydrogen for longer term energy storage. We are not doing that. Why are we not doing that? The reason is simple. It's because only 25% of emissions come from electricity globally, and hydrogen can be more efficiently used both environmentally and economically for other purposes in the chemical sector, in agriculture and transportation. So, that's one, I say that's another option out there, but one that based on my limited experience, I'd be skeptical of.
Good perspective. Thank you. Another one that I wanted to throw your way. There's a question here about if the cost of carbon were included in the energy cost, would basically storage be more competitive versus fossil fuels? And I think maybe just a general, be interesting to get your perspective. Don't normally have someone with your background on here. How did you think about pricing in negative externalities, and kind of obviously can be a slippery slope, but how would you think about that?
Well, look, I think it's a tricky business. I think we kind of agreed in principle that some of these externalities should be priced in. And by the way, some of our provinces, like the province of Alberta, had been doing that on the oil and gas production side. But it's tricky to put a kind of, in a sense, a real price. What is the actual price? You can assign an arbitrary price, but how realistic is it? And the problem you have is energy is so fundamental. The problem with the economics of energy pricing is this: energy is so fundamental that unless you put the prices really high, you don't actually change behavior very much. And of course, if you put them high enough, you then could radically alter the system in ways that are economically extremely destructive. And look, I tell people this repeatedly, you can't merely through a compliance system change an energy system. I go back to what I said about the emerging economies. The fact is, without solutions, long-term storage solutions to the intermittency problem, there are actually no economics, forget about poor economics. There are no economics around an emerging economy trying to develop an entire power system around a base power system around renewables. They simply have to have either fossil fuels or nuclear as the basis of base power today. And so, look, pricing can push you in that direction, but it will not in and of itself solve the technical or economic challenge.
Ramez, do you have any thoughts on that one?
I'm going to disagree slightly with the Prime Minister on that, because I think what we're looking at now, and it depends on the region, there's actually multiple ways to deal with wind and solar intermittency. So as I said, wind and solar are roughly countercyclical. Day, night, we know that that's obvious. That's solvable with batteries. We're on the path to being able to solve the day-night cycle. But the seasonality is the big deal. And so if you look at North America, for instance, in summer, I mean, you've got great sun across a whole lot of the country, but in summer especially, you have a lot more sun than you have wind. And then in winter, you have at the low point of your solar sunlight hitting the continent, but your winds are usually pretty good. They're actually highest in spring, but they're still pretty good in winter. And so you have 3 or 4 different variables that you can play with to achieve less intermittency. One is larger scale grids. Every scientific model, every computer simulation shows that if you build grids that are not just transmitting electricity hundreds of miles, but transmitting it at continent scale, then you can bring in solar from the sunniest regions, wind from the windiest regions, and you have less impact from weather patterns because weather is less and less correlated over distance. And so you go look at, in North America, we can't do this because of regulatory issues. It's impossible to do basically today. Maybe that'll change, at least in the US under new administration, maybe not. We look at China, the longest power lines in China, ultra high voltage DC lines, 3,400 kilometers long. That would stretch from New Mexico to New York, or from Sevilla, Spain to Copenhagen, Denmark. And they are 90% efficient, and they add 1 or 2 cents to the cost of electricity. So long range transmission is a big one. Overbuild renewables. I saw in the chat, somebody, or in the Q&A, somebody asked. The other thing you can do is overbuild renewables and then just not use them. If solar is down to a penny a kilowatt hour and wind is down to a penny and a half a kilowatt hour, you can build those to 2 or 3 times the size that you want, still have it be cheaper than natural gas, and just throw it away and you don't need it. Some software controlled demand. If you can run, today electricity demand peaks in summer, eventually it'll peak in winter probably. You can do things like Google bought Nest because Nest has features like in Texas, when they know it's going to be really hot and the peak demand is going to happen at 3-4 p.m., they'll run the air conditioner a little bit harder at noon to pre-cool the house a bit, to move the peak of demand around so it fits better with the peak of production that you have. So none of those get you away from needing storage, but there's actually multiple variables in the system that you can play with to help get you there. And so I think if you look at China, for instance, China is just building the world's largest high voltage, ultra long range grid. And China, while it's the biggest coal consumer in the world, it's also the #1 deployer of solar, #1 deployer of wind, soon to be #1 deployer of offshore wind, #1 deployer of EVs, and #2 deployer of energy storage only to the US. And they'll pass the US in a couple of years on that. So they're also thinking deeply about how to solve that problem. I'm not saying we don't need to solve long duration energy storage. We need that tool in our toolkit, but the system's a little bit beyond. I don't even think about baseload anymore. I think about orchestration of renewables across geographies with software controlled energy storage systems, software controlled timing of EV charging, and so on, that help fill in the gaps a bit.
Look, and if I could just add, look, I'm not going to dispute any of that. I think there's all kinds of interesting possibilities. I just point out that China is also still growing its fossil fuel usage faster than any country in the world as well.
Yeah, that's true.
Look,
and it's funding coal plants all over the world too. So.
Yeah, what's really important about what Ramez said, though, is that I think the solutions are ultimately hybrid solutions, at least as we move forward. I think that what we have to guard against in this field is the search for the one single answer that's going to solve everything overnight. There are going to be multiple solutions, and the ability to combine them is really going to be what makes significant progress.
Fantastic. Well, I think that's a great place to wrap it up. Thank you so much to our panelists. Thank you, Rob, Ramez, Prime Minister Harper, everyone who is watching. This is an area that we're all extremely passionate about. Clearly, we'd love to speak to other people in the ecosystem, other founders working on this problem. Would love to be supportive in any way. And thank you all so much.
Thank you.
And thanks to everyone that contributed questions. I'm sorry we couldn't get to all of them, but awesome thoughts, and all of them are worthy of further consideration. So we'll try to get back to you after the webinar.
Thanks, everybody. Bye.
Yeah, and Anton, thank you. Thanks, guys.